I think after the year 2000 problems in the telecommunication market, we have seen that a lot of these emerging technologies, new technologies, were brought to the standards. So organizations like network operators, network providers, system suppliers and vendors recognize the benefit from standards to have common set of parameters, parameter values, also to bring the cost down of those components, that these became more important. So there were several standards, and when I joined 2005, Q6 started to work on defining DWDM interfaces for usage in networks by defining, let's say, the single channel interface points towards those kind of transmission system incorporating optical edge drop multiplexers. That was a little bit new because before there were concerns about proprietary systems, but with an approach like the black link methodology, we could just define the single channel points and leave all the middle from the multiplexer over the DWDM system towards the demultiplexer as a kind of black link that allows for implementation-specific approaches from the different network operators, including specific engineering they do. So this kind of recommendation is a good example fitting to your question. This recommendation was GDAP2, later on G698.2 was the official name. So we start with 2.5 gigabit per second, and this was more or less kind of transmission distance, like 450 kilometers with some over the end. So there was some evolution going towards 10 gigabit per second, 40 gigabit per second, 100 gigabit per second. Now we're discussing 800 gigabit per second. So the plan is to get this consented maybe next year. So, and the next step is clear, so it will need to be increased the data rate even further towards 1600 gigabit per second. So there were several changes on this. So we saw in the evolution, we started with a kind of NRZ on-off keying kind of modulation format. And now starting from 100 gigabit per second, that was consented 2018, we even had coherent interfaces on board. And this will be the focus also for the future, because coherent allows to do a lot of things on a link that are really nicely fit to the requirements of operators. Yeah, I think it's not as easy to tell, but some estimate for mind, what I said before, okay, next data rate, 1600 gigabit per second is already, let's say, in work. So we will start a work item on this pretty soon. But besides just focusing on the data rate, there will be much more. So we have also a standard on optical components, optical subsystems. And we have a lot of work creating technical reports where we summarize some of the knowledge that is being used as basis for developing new recommendations. And those kind of technical reports, all the knowledge, this will be influenced by things like artificial intelligence and also usage of networks in slightly different ways than maybe 20 years ago. So, 20 years ago, we were mainly focused on OTN-based operator kind of networks. Now we have a lot of Ethernet traffic. We have data center that generate a lot of traffic. It's not just the traffic generated by the end users like you and me. It's also lots of traffic that's just being generated by the computers doing artificial intelligence, modeling, and all those kind of things. So there's much more traffic we need to consider, and the way how the recommendations are set up, the requirements set up will certainly be influenced by these kind of new technologies like artificial intelligence and other things. And so it's not just a bit rate increase, it will be much more where, for example, question 6, we need to be involved to build the foundation for collecting information to also have data available or knowledge available to be used for future recommendations.